There's a video on YouTube which shows that the sum of all natural numbers from 1 to infinity equals minus 1/12. So I watched that video and I started to think myself about this problem, and this is what I could come up with. I started to group all the numbers in groups of 3, just leaving 1 alone, and then we get this groups of 3, each of them is equal to 9, 18, 27, and so on. They all appear to be multiples of 9. So we can rewrite this expression as 1 plus 9 plus 18 plus 27 plus etc. equals to, let's say, n, as it is there. Now we can factorize this huge sum here, and we can get 9 outside brackets. And if we look closely, we will realize that it's the same sum of all natural numbers, n. So 1 plus 9n equals n, which leads us to 1 equals minus 8n, and n equals minus 1/8. Which is different from what they get in their video, and that puzzled me a lot, because I think that people who got this result were much smarter than me and much more educated in mathematics, and they could prove it from different points of view. On the other hand, this is a very simple way of getting this result. So I wonder if anyone else ever got this before me. I think it should be somewhere written in the history of mathematics. And there is another way of getting this result. If we group numbers in groups of 5, leaving alone 1 and 2. Let's start here. 3, 4, 5, 6, 7. 8, 9, 10, 11, plus 12, plus etc. equals m. It's 25 here and 50 here. Then it will be 75 and so on. So basically they are multiples of 25. So 1 plus 2 plus 25, and we can factorize this expression, this infinitely long expression, in 25 times 1 plus 2 plus 3 plus 4, etc. equals n. And again we get this n in brackets, and very simple equation leads us to an answer that n again equals minus 1/8. And it's very interesting that in general we can show that if we leave alone, if we leave ungrouped, let's say, m numbers, and then we group all other numbers in groups of 2m plus 1 numbers. And so on, it equals n. It's interesting that we can show that this group sum of this group equals 2m plus 1 squared. Sum of this group equals 2 times 2m plus 1 squared. And all other sums in brackets are multiples of 2m plus 1 squared. So again, we can write a very simple equation. Of course, we can simplify this arithmetic sequence, which gives us this. And here we have this again. As we got it before, and now we can show that n equals m times m plus 1 divided by 2 times 1 minus 2m plus 1 squared. And if we factorize it, we will get this. 1 minus 2m minus 1, 1 plus 2m plus 1. And this part here equals minus 2m. This part is 2 times m plus 1. And we can simplify this fraction, and in the end we will get minus 1/8. So whatever number m we take, we are getting the same result, minus 1/8. This is a very interesting result, and it's not minus 1/12. And this is interesting because people in that video, they say that this result is used in physics. And I wonder if those results in physics can be changed if we put their different number to this huge sum. And I have to say it's very convincing in the sense that it's a very simple way of getting this result. It does not involve any difficult mathematics. At the same time, it looks very general. You can use any number here and get the same result.